Hi everyone, this is Raden Wijaya. Today I'm going to discuss about chatbot. So, what is a chatbot? Chatbot is a robot that used to answer questions. How? We can use typing. We can also use voice recognition for the chatbot to understand our query, and then it will return the result according to the programming. In this case, we will reach into the domain of artificial intelligence, but it's a really shallow domain of artificial intelligence. Actually, chatbot is a really new trend that each and every website will use eventually, but actually it's pretty hard to program to have a properly working chatbot. Therefore, many of them will behave funny. The original concept of chatbot that I am going to talk here was originally devised by Andrew Marriott back in year 1999, and it's called Mentor System. Maybe you can find the link on the description and on my last page on the reference page here. Andrew is a really smart guy. He was my professor, I think, on Curtin University, but I've lost touch with him. So Andrew, if you saw this video, maybe you can drop me comments below. I'll be really happy to meet you again one day. The prerequisite knowledge for you to understand my video and to write your own system is object-oriented programming. You need to understand this paradigm because it will make every chatbot system a lot easier. And then you need recursion and regular expression, of course, and you need to understand input-output, for example, XML HTTP request. If you want to have a chatbot that is on your website, or you can try to use voice synthesizer and voice recognizer if you want to be able to talk to your bot. There are two categories of language that you can use to make this program. First, compiled language such as C, PECL. This language is really fast, but there's one drawback. You will need to recompile every time you add a new topic. The other kind of language are the interpreted, for example, the Java or PHP. With this language, you can just add topic without recompiling it. However, there are drawbacks. These languages are much slower, but I don't think it's matter anyway because the speed of typing is a lot slower than the speed of computer processing the input queries. So feel free to choose whatever you want. The basic concept is actually pretty simple. You have multiple states, and one state will represent on one topic. For example, you have this state, headphones. When you're about to talk about headphones, okay, you have some specification, for example, cord length, impedance, and quality of the headphones, build quality, the brand, everything. So, from this, the state diagram, one state will be represented by one topic. One of the topic might have subtopics, so that's why I'm talking before. It's recursion, but it's not done on procedure way. The recursion is done in object, and on programming level, please make one topic as one object. So one object will only talk about one topic. One object, one topic, not one class. Okay, one class can have multiple objects. For example, class animals, perhaps it can have can be translated to object of dogs or cats or whatever you want, and this will make your work a lot easier. And as I said before, the main topic will jiggle. Okay, it will choose, okay, main topic, it will match this regular expression to which topic and this regular expression to which topic. It will jiggle between them. Actually, it's pretty straightforward. And the difficult thing is how do we weigh, for example, if you have two similar regular expressions, how do we weigh this sentence goes here or the sentence goes there? That's what we are about to talk. That's not easy, but it can be done. And sometimes it will result funny because what the computer will output is not always what we intended to, because we are actually playing in artificial intelligence fields here. Regular expression, or regex, is a sequence of characters that defines search pattern. Actually, it's a string that contains a search pattern. You can use regex to find a text on the fields, but in this case, we will use regex to make the computer understand, in quotes, okay, what we're meaning. In this case, we'll use one regex for one meanings, However, if it's hard, you can also use several regex for one meanings. In the example, I'll write it in Perl. Perl, or somebody use PCRE, is Perl compatible regex extension, is available in most programming languages. As you can see on the screen, okay, we have show or get, and then space, me, and then space. And within the bracket, animal, dog or cat, and then space, photo, and the bracket, s, and question marks. What does it mean? It means you will have the computer to choose between show, get, and then we'll have space and then word me, okay, and then animal. It's within this, okay, square bracket, not square bracket, and then less than and greater than bracket. It means it's what we are interested in. We are interested in the animal, and then we have two types, dogs and cat, okay. Actually, you can have another type there. For example, like within square bracket A to Z, it will have a wildcard of any animals, but I don't show it here to make it easy, okay. And then after the animal, we have photo, and within square bracket S, it's optional S, okay. So you can write photo or photos. Computer doesn't need to know, doesn't care about it. It will just, okay, I got the word photo, but it will also accept photos. Actually, it will work with photo and then or photos. It's both the same. So we will capture the animal name, dog and cat, in the variable animal. That's how the regex works. If you have another animal, for example, maybe fish, it will not capture. So we can just put optional there, optional sign for wildcard for any other animals, and you can just, after reading the animal, it's not dog, it's not cat, you will just output, okay, I don't recognize this animal, I don't know. Yeah, that's pretty simple. Let's say we want the computer to process this sentence, tell me more about your dog. We'll have the regex tell, and then space, me, and then space, and then more. Okay, more is optional, so more is within two brackets and with the question mark, so it's optional, and with the string character s, more space. Why? Because if you don't put the space there, okay, it will put like more and about together. It will not recognize as more about. It won't recognize like that. It will recognize more about. Okay, and then your s, it's the same with the more. And then what we are interested here is dog and race. Okay, there are two variables that we will need to capture. Okay, first variable is dog. This way, if you put the race as or dog or race, okay, Labrador, Doberman, Shepherd, and Pitbull, okay, it will choose. If we can put it Labrador, it will return dog as Labrador. If we put Doberman, it will choose dog as Doberman, race as Doberman. But if we put it as dog, it will just return dog. We don't know the race. The code concept revolves around the main topic. The main topic is a descendant of topic, and this subtopic is also descendant of topic class. For example, you have a main topic here, and then you have a topic here, okay, and the subtopic of this, each of the subtopic, is also descendant of the same topic class. For example, you have animal class, and you have a dog class, and you have cat class. Here, both animal and both cat and dog is a descendant of animal, which animal is also a descendant of topic class. And then each of the subtopic will register its trigger to the topic, and then this topic will register to the main topic. So main topic can therefore revolve between this topic and choose the most appropriate topics. In order to do that, we must then record each of the topic popularity, because if the topic is more popular, then it's more relevant to the system, and it means more people are interested in that, and with the more people interested in that, it's more likely that the chatter will engage in that topic. It's easier said than done. Actually, it's really hard to implement and to concept. In this example, we will talk about a really simple concept with several topics. For example, first we have hello topics. Okay, this is our main topics, and then we have introduction topics. It's asking about name, we ask about age maybe, but we will not write the code for it. And then we have animal topics with dogs and cats and what car. Okay, this car is completely irrelevant, it seems so, but we'll talk about it later. On screen you can see the main state. This is where everything begins. Hello is where all the conversation begins, and this hello topic is the main topic, and it is used as the point to exchange to another topics. From the main state we'll jump to introduction topic. Introduction topic will be triggered when the computer first start and ask who is the client. Okay, it will ask hello, my name is what, and what is your name. Actually, this thing can also be expanded. For example, with baby name detection, you can open determine baby name website and then read and match the baby name there with the client's name, so the computer will know whether the client is he or she. And then from here we have two triggers. It's in green. First is a pet topic, and second is the car topic. The decision to put the trigger here is done in programming time. So when you install the pet topic and a car topic, both will add a trigger to introduction topic. If you don't do that, it's fine. It's perfectly fine. However, you might not be able from introduction to directly jump to the car or pet, but it's entirely optional. Animal topic will deal with talking about animals. For example, when the user say I have a cat or I have a dog, okay, then the computer will ask what is the name, and when user answer, for example, my cat is Cathy, answer like Cathy, okay, and then the computer will then trigger to the cat state, because it's remember, okay, the last time user said about cat and the cat name is Cathy, that's the answer, okay, that's the information, and then now we'll pass it to the cat state, and cat state will be activated, animal state is no longer activated. However, if the user says like I have a pet, why user say that? Because animal topics will put a proactive to the main state, put a proactive words, okay, do you have pets, something like that, and then the user will declare I have a pet, and then computer answer what kind of animal. If the user says salty, saltwater crocodile, then computer answer like I don't think you are supposed to keep it, and will pass control to the main state. Why? Because computers render, okay, I know nothing about salty. But if the computers receive answer like dog, then the computer will know user have a dog, and then computer maybe will ask the user what is the name of the dog, or it will just pass the control to the dog state. When the computer receives words but cat, it will enter the cat topic. Okay? So first maybe you can just praise the name, it's a good name, and then ask the age of the cat, and then it will ask like does it play outside, just for fun maybe. If it doesn't love it, okay, and we will say age related problem to the cat, and if got a problem it will give suggestions to the problem. If it's have no problem, it will say glad to hear that, and then it will just exit back to animals. However, if the user don't like to accept the suggestion that the computer give, it will answer like it's hard, and then it will surrender to the animals. But when the user answer yes, my cat loves to play outside, it can also ask a trigger from car topics. For example, does your cat love to be in the car, and then they say like they love road trip, and then it will trigger to the car topic, and the computer will talk about car. It's not hard, but it's quite confusing. And I can tell you that the dog state, it's where the computer will talk about dog. is approximately the same with a cat, but probably with some different states inside. The hardest thing in this system is how you deal with two different topics, but they have the very same regular expressions. For example, like one sentence from the user, it will fit into two regular expressions from two different topics. There is no way that we can guarantee there are no two topics that uses the same regular expressions. So we have some help. Fortunately, first we can choose to the topic that is just talked about, and then we have relevance to the previous topics and which topic is more popular, the one that more people talking about. This data can be gathered when your system is online and many people use it, so you will know the popularity of each and every topics. And let me tell you, random topic is the last thing that you ever wanted to give the client. Why? Because it will make your system look stupid. Random is okay only when you have two topics with exactly the same relevance. But if you want to make proactive system, for example, a system that will talk first to the user, you have to choose only hot topics. You can use the technology that is made by newspaper, so the hot topics will be on the headlines, and then similar to that, the topic that is talked most by the user will be offered to the user, and you can use the data of the interest of the user, get her from another user. For example, like if you have 100 users, okay, and 80 is talking about airliners, then user number 81, okay, you can talk with them proactively using airliners topic. It's a good start. But if the user is not interested, that's fine, just forget it, change topic. Input and output can be done in two ways. First, it's XML HTTP request. You need to understand it, because if you want to have a chatbot that is staying on a website and then you interactively type to the chatbot in the HTML page dialog box, this is the way to do. But if you want to have your chatbot to talk to you, just like maybe like Siri or Alexa, you can just install voice recognition and then voice synthesizer. Such recognition is used so you can talk to the chatbot and it will split your words. After your word is split, and then you can just put your whatever computer is listening into the regex. Okay, after you have the computer listen that and it's in the regex, computer will understand it just like the regular typing way, and then computer will answer you using voice synthesizer. The back end is the same, only the interface is different. The one is XML HTTP request, is text-based, graphics-based, and the other is voice-based user interface. And the final step for you to make a really smart system is to understand data mining. So you have your chatbot to scrape the web. It will read website, for example, like reading the website that contains a list of baby names to determine the gender of the user. Or perhaps you can also create a new topic from a data read from a website. This thing is really hard to do, but if you manage to read a website and then create a new topic from the data that you read from your website, then congratulations, you are really smart. Thank you for watching. I really hope that you find something new that you can learn from this video. I've actually made implementation for this algorithm in PHP, Java, and also Delphi. However, I decided not to share it here. Maybe one day I might share it. And if you need more information, you can always open the website here on the descriptions and here. And I wish you a good day and have a best luck of all.